Hello. I'm guessing you weren't expecting to see me again so soon after yesterday's video on the Dongpo Biota. Well, neither was I, but there's been a development. So last night I got an email from a friend of mine. This is Eamon Doyle, who is the chief geologist for the Burren and Cliffs of Moher Geopark in the Western Island, and we've worked with him on some Carboniferous sponge fossils that he discovered a few years back. But he sent me a little email saying, so why aren't those frond-like structures sedimentary chevron markings? And of course I said, well, Google, what's sedimentary chevron markings? And it turns out it looks like he might be right. So we spent quite a lot of time thinking about these weird frond-like fossils that they were describing as elongate fronds, unnamed, with this sort of chevron type arrangement. I actually kept calling them chevron-likes. And it turns out that there is a possible other interpretation entirely, which fits much better with the evidence that we can see in the pictures, and which was overlooked by all the authors, the reviewers, the editor, me, Lucy, the rest of you, but not Eamon, because Eamon has seen these before. And this is actually quite a rare phenomenon, but it depends on the rheology, the surface consistency of a sticky, muddy surface, and then an object moving over that surface, being dragged over it. And the result is that you get a stacked array of chevron-like impressions in the sediment. And this seems a little unexpected at first glance, but these have been known for quite a long time, and in fact they've been reproduced experimentally, including various different forms of them, some with striated bands down the middle and then chevrons on the outside, others with a single linear sort of streak and then chevrons enclosing that. And then there are others that they didn't reproduce experimentally, with isolated chevrons, like the ones described in this paper from the Dongpo Biota, and with separation of them and no actual line down the middle. And there are various configurations of a tool or an object moving over the surface, which can generate these different forms. And the critical feature seems to be for these uninterrupted chevrons, which is what we'd be looking at here, to have an object which is actually above the surface and be dragging along, scraping into it, rather than something which is on the surface and moving along. There are subtle differences in the exact mechanics of what happens, apparently. These are not common features. They're quite rare things. I've never actually seen one before. I have now, Eamon's mentioned it, possibly a vague recollection of being aware of them as undergraduates, but I've never seen one in the field. Apparently in the Aberystwyth grits of mid-Wales they do occur, but they are rare. So it's no surprise that it didn't spring to mind, because these things look organic. So can we be sure that these are these inorganic sedimentary chevron markings, or could they still be something frond-like which just happens to look like it because it's just a stack of chevrons? And there are several things that we can look for in the photographs. One is that they should be straight, they should be parallel with each other if there are multiple ones there, and they also tend to co-occur with streaks, little linear depressions in the surface, which are caused by other particles being swept along by quite a fast flow, and that would of course all be in the same direction. So there should be little parallel striations in the sediment along with these fronds. And guess what we see? As far as I can make out from everything that is illustrated there, these are indeed inorganic sedimentary chevron markings. That's quite fun. You learn something new every day, and we certainly did. But this is, of course, quite interesting. I mean, it looks so organic. I mean, if you find this on Mars or something like that, then you would be thinking at first glance, wow, that's a fossil. But it's not. I mean, it doesn't even have to be something organic that made the structure that was being sort of swept along by the current, because you get things like mud rip-up clasts. So little bits of mud that have been torn up by turbulent flow over the sea floor, and then they get bits of pebbles or other bits of grain stuck into them, so you get a little spiky ball. And the tool used in these experiments was actually a spiky ball. That was how they generated these chevron markings experimentally in the lab in this paper. So this can happen entirely inorganically. There doesn't have to be life there at all. It might be that to get that consistency of the sea floor, it's helped by having stickiness because of microbial mats. But on the other hand, if that was the case, I would expect to see a lot more of these in the Ediacaran. They used kaolinite, sort of clay sediment, to reconstruct these things in the lab. And that would also be kind of sticky. So it's apparently quite precise differences in the consistency of the surface that lead to either getting chevrons, not getting chevrons, getting different types of them. And so you end up with a totally different arrangement of traces depending on what the circumstances were. Okay, so that means we have to backtrack a little bit from the previous video in terms of what we now know, because partly it reduces the biodiversity of the Dongpo assemblage by 1, which takes it down to 9 taxa, which isn't an enormous difference, but it's significant when you've got so few things. And it takes out these frond-like organisms entirely, apart from the fact that Aspidella is still there, these holdfasts. So there was something frondy there, probably. But then I also spent quite a lot of time discussing potential similarities between this and Ylingia, which is this problematic fossil of them, which has been described as a worm-like thing with its trail behind it. And I raised several arguments why I didn't think that was the best explanation for it anyway, that a long elongate frondy type thing was probably more reasonable in any case. But without the similarity to Ylingia, it made it much harder, or it makes it much harder to tie it in with positive evidence in that direction. So before I came onto that, I left it as Ylingia has to be really left ambiguous. It's in limbo because there are various features that make me think that that isn't a trail. It's too narrow, it tapers evenly into the body part. There's no sharp distinction between the body and the trail. You get traces of the impression of the surface texture in the areas that should be the trail, which doesn't make sense if it's moving and smearing it out. So for various reasons, I still do not think Ylingia makes sense as it was described, as a worm-like thing with a trail behind it. And given that in that case it's better understood as an elongate, frond-shaped thing, then we still are left with the situation where it looks like it has the same body form, the structure is different to the petalonomans. Does that mean it can't possibly be an elongate frond-like thing? Of course not, because our knowledge is incomplete. But we also don't have the continuity with the frond-like things. Now that we have to get rid of the Dongpo one out of the equation, we're left with still, it's left ambiguous. We need more information to be able to say what Ylingia is. I suspect that there will be more finds in future that show that there are similarities, continuity to the petalonomans, but at this stage we don't have it. So I'm going to leave that there in sort of limbo and let the future decide what it actually is, because I don't think it's what it was described as. The question is, could it be something much more mundane for Ediacaran communities? Or is it something completely distinct again? Is it something which we just have no frame of reference for because, like the time before we first discovered the Ediacaran biota as a whole, We just have nothing within our knowledge base that comes very close to it. Right, there you go. That was a bit of a surprise. I will leave it there because there's no point dragging this on. But it just goes to show the value of experience in all sorts of fields. So sedimentary experience working in deltaic conditions out in the Carboniferous in Ireland is what has, to me convincingly, solved the issue of what these Dongpo fronds really are. So thank you, Eamon. And that's really interesting. It's not at all what we expected. And it just goes to show how inorganic circumstances can really mimic something that looks like a fossil. It fooled me. Right, I best be getting on, but see you again soon. Enjoy.